Hello there. In this video, we're going to take those properties of exponents that we learned about in the previous video, and we're going to apply them to solving problems and simplifying expressions as much as possible. Now, it's important to remember that, again, our base will never be 0. So we don't have to worry about, okay, yeah, I can only do this if our base is not equal to 0. We already logged that away in our mind. So any base can't equal 0, okay? We'll note that now so we can move forward with these problems. Okay, so we've got a couple things here we can do. I've got x squared times y cubed all over x to the negative 2, y to the power of 4th. Now, there's a couple ways you can approach this. I see this negative exponent. When you're simplifying problems like these, you always want positive exponents only in your answer, okay? So what I'm going to do is, because this property, this x to the negative 2, that's a negative. Remember, we have the property that x to the negative a in the denominator can be x to the a, which means I can take this and move this to the numerator. So that's x squared times another x squared times y cubed. And then this y to the 4th is still positive, so we'll keep that down there. Now here we've got our addition rule, so that means we're going to add 2 and 2 together, so I'm going to leave me with x to the 4th. And then here we have our subtraction rule where we got 3 minus 4, so that's y to the negative 1. Now we've got a negative exponent. We're leading with the 3, which is why I want to write it in the numerator, but we can always kick it down to a denominator, so x to the 4th is positive. That'll stay in a numerator. But this negative means my final answer is going to be in fraction form. And to make it positive, I move it to the denominator. Now you can write y to the 1st, or we can just leave it as is, and we're done. Now, if you want a second way of solving this, you can use the difference property twice. So 2 minus a negative 2. That'd be 2 plus 2, which is x to the 4th, and then repeat the process. 3 minus 4 is y to the negative 1, and we see we still get the same answer. So the choice is up to you. It depends on how you see the properties and what properties you see first and what you like best. Okay, so here we go. We got a square root of x to the 6th, y squared, z to the, we have to remember this is z to the 1st. It's always good to write in those exponents. But remember, square root of x is the same as saying x to the 1/2 power. So I'm going to rewrite this as x to the 6th, y squared, and z to the 1st, all to the 1/2 power. And what I can use here is my multiplication property. I can distribute this 1/2 to each of these exponents. And so we get x to the 6 divided by 2, and then we get y to the 2 divided by 2, and then z to the 1 divided by 2. Now we simplify. 6 divided by 2 is 3. 2 divided by 2 is 1. I won't write the 1. And then z to the 1/2, I can't simplify. Now, there is that rule I mentioned in the previous video that when we're taking the square root of x squared, this is equal to the absolute value of x, or the square root of x squared. Those are interpreted to be the absolute value of x. And it really comes down to what's our end result. If our end result has an odd exponent, then we will put the absolute value signs, because something cubed or something to the 5th can always result in a negative. Negative 1 to the 3rd is still negative 1. But if it were to an even power, negative 1 to the 4th power is positive 1, which means we could drop the absolute value as the result would always be positive. And I see I've got an odd exponent right there and right there. So what I'm going to do is I'm going to put my absolute value around both of those. And then times z to the 1/2. And you can rewrite this as square root of z if you want to. I'm not going to. I'm going to leave that as my final answer. All right, here we go. We got the quantity x cubed, y to the, we'll remind ourselves that that's to the 1st, z to the 4th, all to the power of negative 2, all over w cubed times x to the negative 4th times y to the negative 3rd times z to the 8th, all to the power of 0. That denominator is looking quite hefty, but we see we've got this 0 here, okay? The 0 can be distributed. So if we want to distribute it, we are perfectly within our right to do that. But remember what I said, anything to the power of 0 is equal to 1. It doesn't matter how big this expression is. It's all to the power of 0, which means we can cancel it out to be 1. I point out the distribution to show you that if we do distribute it, 3 times 0 is 0, which means that would cancel. Anything to the power of 0 is 1. Negative 4 times 0, that gets you 0, so that would cancel. Negative 3 times 0 is 0. 8 times 0 is 0. But the whole thing can cancel out. So let me rewrite the numerator. X cubed, y to the first, z to the fourth, all to the negative 2. So that's all I'm left with to deal with right now. So let's go ahead and distribute this negative 2. We multiply it to all our exponents. We get x to the negative 6th, y to the negative 2, and z to the negative 8th. Now recall our property that when x is to a negative exponent, we can create a fraction with 1 in the numerator and x to that positive exponent in the denominator. So that's what we're going to do here. Each of them is negative, so nothing's going to stay in the numerator. So I'm going to write 1 over, and then I'm just going to rewrite each of these with a positive exponent. X to the 6th, y squared, and z to the 8th. And we're done. Final problem. Looked at this one. This one is quite hefty. We've got a 2 here and a 3 here. Well, we're going to want to start with the outside first. So we'll do 3 times 2, and then 3 gets multiplied to this thing as if it were 1. So let's rewrite this. I'm going to Now the reason why I do that is so I can distribute this 6 and distribute this 3 evenly. So I got, now here we've got a part of the problem where we're dealing with coefficients now. So 2, remember this 2 has a first power. Likewise, this 8 has a first power. Okay, so when we multiply these, 1 times 6, that'll give me 2 to the power of 6. 3 times 6, that'd be x to the 18th. Negative 2 times 6, that's y to the negative 12. And 2 times 6, that is z to the power of 12. 1 times 3, we're on to the denominator now, so that's 8 cubed. Negative 2 times 3 is to the negative 6th. Negative 2 times 3, that's y to the negative 6th. And then 2 times 3 is z to the positive 6. Now, really quickly, some calculations off to the side. Let's take care of this 2 to the 6th and 8 cubed right away. So 2 to the 6th over 8 cubed, this would be 64. 8 cubed is 512. Well, we can probably simplify that differently. Let's start over 2 to the 6th, and 8 is 2 cubed, so 2 cubed, which would be 2 to the 6th over 2 to the 9th. And then this would just be 1 over 2 to the 3rd, which would be 1 over 8. Beautiful. So 1, I'll leave some space, over 8. And then for the rest of this, let's just use our subtraction rule since I'm running out of space. So we got the x's here. So that's 18 minus a negative 6. That's 18 plus 6, so that's 24. So I get x to the 24th up top. I've got y to the negative 12th, y to the negative 6th. That's a negative 12 minus a negative 6. So this is plus right here, and that gets us a negative 6 overall. Now that can automatically be kicked to the denominator. So that's y to the positive 6. And then we've got the z's, which are nice and positive. So that's 12 minus 6 equals 6. We get z to the power of 6, and then we are done. Please feel free to leave a like, subscribe, and comment on the video. If you would like more videos like this in the future, please let me know, and I will see you next time. Thanks for watching.